chapter inverse trigonometric functions. So let's continue in this session. We were doing the problems in exercise 2.2, right? We were doing exercise 2.2, so we'll continue with that. Okay. So before that, I just recall you the PVB, the principal value branches of inverse trigonometric functions. So we have grouped this into three, right? Sine inverse, then tan inverse, then cosec inverse, right? So these are the principal value branches of these functions are all minus first one sine inverse, it is minus pi by 2, closed interval minus pi by 2 comma pi by 2, and tan inverse, it is open interval minus pi by 2 pi by 2. Similarly, the cosec inverse PVB was closed interval minus pi by 2 comma pi by 2 minus set 0. Okay, similarly we have grouped the other three together, and we studied the PVB of inverse trigonometric functions. Okay. And yesterday we studied a property also. Property related to inverse trigonometric function, that is nothing but sine inverse of sine theta is equal to theta, and this property is valid for all the inverse trigonometric function. Similarly, we have another property for that, that is nothing but sin of sine inverse x is equal to x. This result also hold for all the inverse trigonometric functions. Okay. So we can discuss the rest of the problems in exercise 2.2. First one is we have to find out the simplest form of the given problem, right? Tan inverse of x by root of a square minus x square. Tan inverse of x by root of a square minus x square. The domain is mod x less than e. Domain is mod x less than e. We have to find the simplest form of this particular problem. Tan inverse of x by root of a square minus x square. For that, I am putting x is equal to a sine theta. Okay. Here I am substituting, instead of x I am giving a sine theta. So what can you say about x by a? If x is a sine theta, x by a is nothing but sine theta, right? X by a is equal to sine theta. And according to the definition of inverse, we can write this one as sine inverse of x by a is equal to theta. Isn't it? If sine x is equal to y, we can write, if sine inverse x is equal to y, we can write sine y as x. Right. So using that property, we can write x by a. If x is equal to a sine theta, we got x by a as sine theta. So we can write this as sine inverse of x by a is equal to theta. This theta. Okay, is that clear to you all? Now consider the problem, that is tan inverse of x by root of a square minus x square. So here, instead of in the place of x, I am going to give the value a sine theta. That is tan inverse of a sine theta divided by root of a square minus a sine theta the whole square. Isn't it? Instead of x, I am giving the value a sine theta. So tan inverse of a sine theta by root of a square minus a sine theta the whole square. This can be written as tan inverse of a sine theta divided by root of a square minus a square sine square theta. Isn't it? A sine theta the whole square can be written as a square sine square theta. So here you can take a common, right? tan inverse of a sine theta divided by a into root of 1 minus sine square theta. Here we are taking, here in this one you can add one more step, that is denominator. In denominator you can simplify it as take a square outside from both of the term. So we'll get a square into 1 minus sine square theta. So what is root of a square? It is nothing but a. So that is given in this step. That is tan inverse of a sine theta by a into root of 1 minus sine square theta. So we can cancel this a, isn't it? We can cancel this a. So it will become tan inverse of sine theta divided by root of 1 minus sine square theta. So what is root of 1 minus sine square theta? It is nothing but cos theta, right? Sin theta divided by cos theta. Sin theta divided by cos theta. It is obtained by using the identity cos square theta plus sin square theta is equal to 1. Okay, from this we get that root of 1 minus sin square theta is cos theta. So tan inverse of sin theta by cos theta will become tan inverse of tan theta, that is equal to theta. Okay, we can't stop here. Since the problem is in the problem function question is in the form of x. Sorry, it is a function of x. Tan inverse, the given question, it is a function of x. So we have to convert the result also into in terms of x. So here we have obtained it in terms of theta. So we have to convert this. Okay. Theta can be written as sine inverse of x by a. Since we have substituted x is equal to a sine theta, from this we have already obtained that sine inverse of x by a is equal to theta. So replace that value instead of theta. That is equal to sine inverse of x by a. So this is the simplest form of tan inverse of x by root of a square minus x square. I hope this is clear to you all. Next question is tan inverse of 3a square x minus x cube divided by a cube minus 3ax square. The domain is given a greater than 0 minus a by root 3 less than x less than a by root 3. Okay, we don't have to worry about the domain for this type of questions. Just you have to find out the simplest form by substituting any values for x. Okay, here I am going to take x is equal to a tan theta. Take x is equal to a tan theta. Okay, so similarly in the previous question, x by a will become tan theta. Then tan inverse of x by a will become theta. Okay, now consider the question. We have to put the value of x in that question. That is tan inverse of 3ax square x minus x cube by a cube minus 3ax square. That is equal to tan inverse of 3a square into x will become a tan theta. I'll write in a new page, okay? Tan inverse of 3a square x minus x cube by a cube minus 3ax square. So this can be written as tan inverse of 3a square into a tan theta minus a cube tan cube theta divided by a cube minus 3a into a square tan square theta. Isn't it? Instead of x, I am giving the value a tan theta. So x cube will become a cube tan cube theta and x square will become a square tan square theta. So we can write this as tan inverse of 3a cube. Isn't it? 3a cube tan theta minus a cube tan cube theta divided by a cube minus 3a cube tan square theta. Okay. So can you see any peculiarity in this? A cube is common in denominator as well as numerator, right? So we can take a cube outside. On taking a cube outside, it will become tan inverse of a cube into 3 tan theta minus tan cube theta divided by, from the denominator also you can take a cube outside. So a cube into 1 minus 3 tan square theta. Okay, so we can cancel these a cube. Since they are common, we can cancel this. So it will become tan inverse of 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Okay, so which is the identity? 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. It is nothing but tan inverse of tan 3 theta. Tan inverse of tan 3 theta. So we can use the property of inverse, right? The property of inverse was tan inverse of tan x is equal to x, right? So similarly, tan inverse of tan 3 theta can be written as 3 theta. But we cannot stop here because we have to convert this theta value in terms of x, because our question is a function of x, right? So we have to convert this. So substituting the value for theta, it will become 3 into tan inverse of x by a. 3 into tan inverse of x by a. Okay, is that clear to you? Now, the next question is find the values of the following. Okay, we have to find the values. First one, tan inverse of 2 cos 2 sine inverse of 1 by 2. Find the value of tan inverse of 2 cos of 2 sine inverse 1 by 2. So how you can find the value of this particular function? If you are given a function like this, f of g of x, right? If you are given a function like this, we start from here. We start from g of x, then we solve that, right? So similarly, we have to start from the values inside the bracket. So start from here. So do you know the value of sine inverse of 1 by 2? Yesterday we studied problems related to this, right? So let sine inverse of 1 by 2 be theta. So we can write this as 1 by 2 is equal to sine theta, right? So we can say that it is nothing but pi by 6, right? Sine pi by 6 is equal to 1 by 2. So we can say that theta is equal to pi by 6. Theta is equal to pi by 6. And now what we have to do? We have to substitute this value in that particular equation. We have got theta is equal to pi by 6. So put that value, that is tan inverse of 2 cos 2 into pi by 6. Sine inverse of 1 by 2 is pi by 6. So it will become 2 into pi by 6. So we can cancel this. That becomes tan inverse of 2 cos pi by 3. Right? 2 and 6 got cancelled. So it will become cos pi by 3. So what is the value of cos pi by 3? Tan inverse of 2 into cos pi by 3 means it is cos 60. Right? Cos 60. What is the value of cos 60? It is 1 by 2. So it will become 1 by 2. Tan inverse of 2 into 1 by 2. So what is the value? It is nothing but tan inverse 1. 2 and 2 got cancelled. So tan inverse of 1. Tan inverse of 1 is nothing but pi by 4. What is the value of tan inverse of 1? It is pi by 4, right? So the value of tan inverse of 2 cos 2 sine inverse 1 by 2 is pi by 4. there is one more problem to find out the simplest form, okay? Uh, Similar to the problems that we did earlier. That is tan inverse of cos x by 1 minus sin x. This is in your examples. Okay, this is not an exercise question. This is an example question. Tan inverse of cos x by 1 minus sin x minus 3 pi by 2 less than x less than pi by 2. This is the domain of that particular function. Okay, we have to find out the simplest form of this particular problem. So let's see. We know the identity cos 2x, right? Cos 2x can be written as cos square x minus sin square x, right? Cos 2x can be written as cos square x minus sin square x. So what is a half angle formula for this? Cos 2x can be half angle formula is nothing but take the half of that angle. So half of 2x means x, right? Cos x can be written as cos square x by 2 minus sin square x by 2. From cos 2x is equal to cos square x minus sin square x, we know that cos x is equal to cos square x by 2 minus sin square x by 2. Similarly, we can write this question tan inverse numerator is cos x, right? So we can write this as cos square x by 2 minus sin square x by 2 divided by, it is 1 minus sin x. And we know that sin 2 theta is equal to 2 sin theta cos theta. Isn't it? Sin 2 theta is equal to 2 sin theta cos theta. So what is a half angle formula for sin theta? Sin theta will become 2 sin theta by 2 cos theta by 2. Right. So sin x can be written as, I'm writing this 1 minus sin x. I'm writing in a separate page, okay? That is 1 minus sin x. I'm going to write this as cos square x by 2 plus sin square x by 2. That is 1 can be written as cos square x by 2 plus sin square x by 2. That is an identity. In the trigonometric function, we have already studied that cos square x plus sin square x is 1. So instead of 1, I am writing cos square x by 2 plus sin square x by 2. And instead of sin x, I am going to write 2 sin x cos x. Okay, 2 sin x by 2 cos x by 2. It is half angle formula, right? 2 sin x by 2 cos x by 2. Is that clear to you all? 1 minus sin x can be written as cos square x by 2 plus sin square x by 2 because cos square x by 2 plus sin square x by 2 is the value 1. And instead of sin x, by using half angle formula, we have rewritten as sin x as 2 sin x by 2 cos x by 2. Okay. Now coming back to the question, tan inverse of the numerator we have already rewritten in terms of cos square x by 2 and sin square x by 2, right? Cos square x by 2 minus sin square x by 2 whole divided by, now 1 minus sin x can be written like this, isn't it? So cos square x by 2 plus sin square x by 2 minus 2 sin x by 2 cos x by 2. Okay, now what can you say about this, about numerator? It is in the form of a square minus b square, right? So we can write it as a plus b into a minus b. Isn't it? A square minus b square can be written as a plus b into a minus b, right? So similarly, cos square x by 2 minus sin square x by 2 can be written as cos x by 2 plus sin x by 2 into cos x by 2 minus sin x by 2. Okay, and the denominator is in the form of a square plus, the denominator is in the form of a square plus b square minus 2ab, right? This is a square, that is instead of a it is cos square, right? Cos square x by 2 plus sin square x by 2 minus 2 sin x by 2 cos by 2. Isn't it in the form of a square plus b square minus 2ab? So we can write this as a minus b the whole square. Isn't it? A minus b the whole square is nothing but a square plus b square minus 2ab. So the denominator can be written as what is a here? It is nothing but cos x by 2. Cos x by 2 minus sin x by 2. B is sin x by 2 whole square. Right? Cos x by 2 minus sin x by 2 the whole square. Is that clear to you all? Now what we can do? Is there any common factor in numerator as well as denominator? Yes, right. Cos x by 2 minus sin x by 2 is both in denominator as well as numerator. So we can cancel that part. That is cos x by 2 minus sin x by 2, and from this you can cancel 1. Cos x by 2 minus sin x by 2. So what will it become? It will become tan inverse of cos x by 2 plus sin x by 2 divided by cos x by 2 minus sin x by 2. Okay, so now I'm going to divide both the numerator as well as the denominator by cos x by 2. We are going to divide both the denominator and the numerator by cos x by 2. So it will become tan inverse of cos x by cos x by 2 will become 1, right? 1 plus then sin x by 2 by cos x by 2 will become tan x by 2 divided by, again in the new denominator also we are dividing with cos x by 2, right? So dividing by cos x by 2 we'll get 1 minus, similarly if we divide tan x by 2, sorry, cos x by 2 here, we'll get tan x by 2. Is that clear to you all? We got on dividing the numerator and denominator by cos x by 2, we got the function as tan inverse of 1 plus tan x by 2 divided by 1 minus tan x by 2. Okay, now again I am making an adjustment. That is, instead of 1, I am going to write tan pi by 4. Tan inverse of, instead of 1, I am going to write tan pi by 4. Isn't the value of tan pi by 4 1? So we can write instead of 1 as tan pi by 4 plus tan x by 2 divided by 1 minus tan x by 2 into tan pi by 4. Here you can only see tan x by 2, but tan x by 2 into 1. Consider it as tan x by 2 into 1, and this 1 can be written as tan pi by 4. So we are making an adjustment, right? So tan inverse of tan pi by 4 plus tan x by 2 divided by 1 minus tan x by 2 into tan pi by 4. Now, do you see any identity in this, in the numerator and denominator? Do you see any identity? It is nothing but tan of x plus y, isn't it? Tan of x plus y is nothing but tan of x plus y by 1 minus tan x tan y, right? So we can write this one as tan inverse of tan of pi by 4 plus x by 2. Okay, so I'm writing it as tan inverse of tan of pi by 4 plus x by 2. So simply we apply the identity. Okay, it is nothing but tan of x plus y is equal to tan x plus tan y divided by 1 minus tan x tan y. Here instead of x it is pi by 4 and instead of y it is x by 2. Okay, we applied that identity. So now we know that by using the property of inverse, we can say that tan inverse of tan x is x. So here in place of x, we can say pi by 4 plus x by 2. So what is the value of it? Pi by 4 plus x by 2. Okay, so we have got the simplest form of that particular function. It is nothing but pi by 4 plus x by 2. Next question is tan 1 by 2 into sine inverse of 2x by 1 plus x square plus cos inverse of 1 minus y square by 1 plus y square. Here mod x is less than 1, y is greater than 0, and xy is less than 1. Tan 1 by 2 into sine inverse 2x by 1 plus x square plus cos inverse of 1 minus y square by 1 plus y square. So here you can see that in the inside the bracket you can see it is a function. First part is a function in x, in a variable x, as well as the second function is a function in variable y. Okay, so we have to give two substitution here, that is for x as well as y. So here I am taking x is equal to tan theta. I am giving x is equal to tan theta and y is equal to tan phi. Okay, y is equal to tan phi. So this equation will become tan 1 by 2 into sine inverse of 2 tan theta divided by 1 plus tan square theta plus cos inverse of 1 minus tan square phi by 1 plus tan square phi. Okay, so by putting x is equal to tan theta and y is equal to tan phi, the equation become tan 1 by 2 into sine inverse of 2 tan theta by 1 plus tan square theta plus cos inverse of 1 minus tan square phi by 1 plus tan square phi. Okay, so this is the identity. You know the identity, right? 2 tan theta by 1 plus tan square theta is nothing but sine 2 theta. So this can be written as sine inverse of sine 2 theta plus cos inverse of, this is the identity, 1 minus tan square phi by 1 plus tan square phi is nothing but cos 2 theta, right? So we got tan 1 by 2. Sorry, this is phi. Since it is, we have already given it as tan phi, so we have to write it in terms of phi itself. Okay, so it is cos inverse of cos 2 phi. Okay, so by using the property, what we can say, sine inverse of sine 2 theta will become 2 theta, as well as cos inverse of cos 2 phi will become 2 phi, right? So tan 1 by 2 into 2 theta, sine inverse of sine 2 theta will become 2 theta plus cos inverse of cos 2 phi will become 2 phi. Now what I am going to do is that since 2 is common in both the terms, we are taking 2 outside. Okay, we are taking 2 outside, that is 2 into theta plus phi. 2 into theta plus phi. So what will become? It will become tan of, this 2 will get cancelled, right? So it will become tan of theta plus phi. It will become tan of theta plus phi. Okay, so here we can write this as tan theta plus tan phi by 1 minus tan theta tan phi. We are applying the identity tan of x plus y is equal to tan x plus tan y by 1 minus tan x tan y. Okay, so here instead of x it is theta and instead of y it is phi. So tan of theta plus phi will become tan theta plus tan phi by 1 minus tan theta into tan phi. Okay, so here we have already given the substitution as tan theta is x, right? So tan theta can be written as x, as well as tan phi was y. So tan phi can be written as y. So x plus y by 1 minus x into y. X plus y by 1 minus x into y. Next question is to find the values. Find the values of the following. First one, sine inverse of sine 2 pi by 3. Sine inverse of sine 2 pi by 3. So if we apply the property sine inverse of sine x is equal to x, we get that the value of theta will become 2 pi by 3. Isn't it? The value of theta will become 2 pi by 3. And we have to check whether this 2 pi by 3 belongs to the principal value branch of sine inverse, right? So does 2 pi by 3 belongs to the PVB of sine inverse? For that we need to know the PVB of sine inverse. What was that? PVB of sine inverse is nothing but closed interval minus pi by 2 comma pi by 2. right? PVB of sine inverse is closed interval minus pi by 2 comma pi by 2. Does 2 pi by 3 belongs to this PVB? Does 2 pi by 3 belong? How will you check that? 2 into 180 by 3. 2 pi by 3 means 2 into 180 by 3, right? So if we cancel this, it will become 60, that is equal to 120 degree. Does 120 degree belongs to this principal value branch? No, right. It only consists of values in between minus 90 and 90. 120 is greater than that. So it doesn't belongs to the principal value branch. So we have to find out the value that is the angle that is equivalent to 2 pi by 3 that occurs in between this PVB. Okay, we have to find the angle that is equivalent to 2 pi by 3 that will occur in the PVB of sine inverse. So for that, I am going to split this 2 pi by 3. Okay. I am going to write this 2 pi by 3 as 3 pi minus pi by 3. Can I write like that? Can I write like that? 2 pi by 3 is equal to 3 pi minus pi by 3. We can write it like this. Because 3 pi minus pi will give you 2 pi, right? So 3 pi minus pi by 3. So on dividing both the terms 3 pi and pi by 3, what we will get? That is, we are splitting this 3 pi by 3 minus pi by 3. Okay, I am giving the denominator to both the terms in the numerator. So it will become pi minus pi by 3. It will become pi minus pi by 3. So we have converted 2 pi by 3 into pi minus pi by 3. So what we can say after in the question sine inverse of, it was sine inverse of sine 2 pi by 3. Now we have splitted this as sine inverse of sine of pi minus pi by 3. Pi minus pi by 3. Here you can see that pi minus pi by 3 means it is the second quadrant, right? Pi minus pi by 3, it is in the second quadrant. In the second quadrant, you know sine is positive. That is why sine of 2 pi by 3 is written as sine of pi minus pi by 3. Okay. Now, applying. So, what is the value of sine of pi minus pi by 3? By using the reduction formula, sine of pi minus pi by 3 can be written as sine inverse of sine pi by 3. Right, pi minus sine of pi minus pi by 3 can be written as sine of pi by 3. Now, by applying the property of inverse, we can say that sine inverse of sine x is equal to x. Here in place of x is pi by 3. So, sine inverse of sine pi by 3 is nothing but pi by 3. Sine inverse of sine pi by 3 is nothing but pi by 3. Is that clear to you? Next one is tan inverse of tan 3 pi by 4. Tan inverse of tan 3 pi by 4. Okay. So we have to find out the value of this particular. So tan inverse of tan x is equal to x. So by applying that property, we'll get 3 pi by 4. Right. Tan inverse of tan 3 pi by 4 is equal to 3 pi by 4 using the property of inverse. Thus 3 pi by 4 belongs to the PVB of tan inverse. The PVB of tan inverse was open interval minus pi by 2 comma pi by 2. Right. We have to check this 3 pi by 4 belongs to this particular branch. So how will you check 3 into 180 by 4? Right. So 4 times 4, 16. 20 is 45. 3 into 45 means it is 135 degree. Thus that 135 degree belongs to this branch. No, right. 135. That means 3 pi by 4 doesn't belongs to 3 pi by 4 doesn't belongs to open interval minus pi by 2 comma pi by 2. 3 pi by 4 doesn't belongs to open interval minus pi by 2 comma pi by 2. Okay, so what we have to do, we have to find out the corresponding value of 3 pi by 4 that is in the branch of tan inverse, principal value branch of tan inverse. Okay, for that I am going to split this 3 pi by 4. Okay, 3 pi by 4 can be splitted as 4 pi minus pi by 4. Right. 3 pi by 4 can be splitted as 4 pi minus pi by 4. So we get pi minus pi by 4. I'm not simplifying it. You can do it as a homework like 4 pi minus pi by 4. You will get pi minus pi by 4. It's very simple. So we are going to substitute that in the equation. That is tan inverse of tan of pi minus pi by 4. Our question was tan inverse of tan of 3 pi by 4. So instead of 3 pi by 4, we wrote it as tan inverse of tan of pi minus pi by 4. What is the value of tan of pi minus pi by 4? What is the value of tan of pi minus pi by 4? You have to apply the reduction formula, right? Pi minus pi by 4 means which interval? Sorry, which quadrant? Pi minus pi by 4 means it is the second quadrant. This is 0, this is pi by 2, this is pi, and this is 3 pi by 2. Okay, so the angles in the second quadrant can be, the general representation is nothing but pi minus theta. Here it is nothing but pi by 4. So pi minus pi by 4 belongs to the second quadrant. And in the second quadrant, what can you say about the function tan? Is tan function positive or negative? Tan function is negative, right? Here all the trigonometric functions are positive. Here sine and its reciprocal cosec are positive. Here tan and cot are positive. Similarly, here cos and sec are positive, right? So here you can say that tan is negative. In the second quadrant, tan is negative. So we get the answer as tan of pi minus pi by 4 as minus tan pi by 4, right? It is nothing but minus tan pi by 4. Since it is in the second quadrant, all the tan functions are negative. So we are putting a minus here, right? Minus tan pi by 4. Now I am taking this minus outside. That is minus tan inverse of tan pi by 4. So tan inverse of tan x is equal to x, right? So by applying that property, we can say that the value is pi by 4 and here there is already a minus. So it will become minus pi by 4. It will become minus pi by 4. Third one is sine inverse of sine 3 pi by 5. Okay. So again, if you apply the property sine inverse of sine x is equal to x, sine inverse of sine 3 pi by 5 will become 3 pi by 5. But does 3 pi by 5, the angle 3 pi by 5 belongs to the principal value branch of sine inverse? Let's see. 3 pi by 5 means 3 into 180 by 5. Right, 3 into 180 by 5. So by cancelling it, we get 3 times, then it is 30, that is 36, right? 3 into 36 means 6 3s are 18 and 108, right? It is 108 degree. And what was the principal value branch of sine inverse? It was closed interval minus pi by 2 comma pi by 2. Closed interval minus pi by 2 comma pi by 2. Does 108 degree belongs to this particular branch? No, right? So 3 pi by 5 doesn't belongs to minus pi by 2 comma pi by 2. Okay, it doesn't belongs to that particular PVB. So what we have to do, we have to find out the corresponding angle. For that we have to split 3 pi by 5. So how will you split 3 pi by 5? We can split this as 5 pi minus 2 pi by 5. Right? 3 pi by 5 can be written as 5 pi minus 2 pi by 5. Isn't it? So this will become pi minus 2 pi by 5. It will become pi minus 2 pi by 5. Okay. Now coming back to the question. Sine inverse of sine 3 pi by 5 can be rewritten as sine inverse of sine of pi minus 2 pi by 5. Sine 3 pi by 5 we have rewritten as pi minus 2 pi by 5. Okay, sine of pi minus 2 pi by 5. So pi minus 2 pi by 5 means this is pi. Pi minus 2 pi by 5, we are subtracting an angle from pi, so it will come in the second quadrant, right? It will come in the second quadrant. In the second quadrant, we know that sine is positive. In the second quadrant, sine is positive. So what is the value of this sine inverse of sine 2 pi by 5? In the second quadrant, sine is positive. So sine of pi minus 2 pi by 5 is equal to sine 2 pi by 5. Right. Now applying the property, we'll get it as 2 pi by 5. Right. Sine inverse of sine x is equal to x. So instead of x, it is 2 pi by 5. So we can say that sine inverse of sine 2 pi by 5 is equal to 2 pi by 5. Is that clear to you? Now we are moving on to the next question. That is cos inverse of cos of 7 pi by 6. Cos inverse of 7 pi by 6. So 7 pi by 6 can be written as 12 pi minus 5 pi by 6. Right. 12 minus 5 is 7. So 7 pi by 6 can be written as 12 pi minus 5 pi by 6. Okay. So here you will get 12 pi by 6 minus 5 pi by 6. 12 pi by 6 can be written as 2 pi, right? 2 pi minus 5 pi by 6. Okay. So why I took 2 pi? It is because when you consider the sign of functions, here you can see that it is 2 pi. When you subtract an angle from 2 pi, it will come here, right? If you subtract an angle from 2 pi, it will come in the fourth quadrant. Fourth quadrant, we know that cos is positive, right? So we have rewritten as cos of 7 pi by 6 can be now rewritten as cos of 2 pi minus 5 pi by 6. Okay, cos of 2 pi minus 5 pi by 6. Cos inverse of cos of 2 pi minus 5 pi by 6. Okay, so what is the value of cos of 2 pi minus 5 pi by 6? It is positive cos, right? Cos of 5 pi by 6. Since it is in the fourth quadrant, it is positive. So cos inverse of cos 5 pi by 6. So what is the value here? We are applying the property of inverse trigonometric function, that is cos inverse of cos x is equal to x. So here the value is nothing but 5 pi by 6. Okay. Now we are moving on to another type of problem. It is not solved applying identity and all. It is entirely different from all these problems. Okay. So that is tan of sine inverse 3 pi by 5 plus cot inverse of 3 by 2. Tan of sine inverse of 3 by 5 plus cot inverse of 3 by 2. Here can we apply an identity? No, right. So we have to find out the values of sine x as well as cos x. Okay. Here it is given as sine inverse of 3 by 5 and cot inverse of 3 by 2. It is not standard values of sine and cot, right? So we have to find another way to solve this problem. For that, I am going to let sine inverse of 3 by 5 be x. Sine inverse of 3 by 5 be x. So we can write 3 by 5 as sine x. We can write 3 by 5 as sine x. Okay. From this, can you find out the value of cos x or tan x? Can you find out? Consider the triangle, right angle triangle. Let this angle be x. Okay, here it is given as sin x is, we have already got that sin x is 3 by 5, right? Sin x means opposite side by hypotenuse. What is opposite side of this angle x? This one, right? So this is 3 and hypotenuse is 5. Sin x is nothing but opposite side by hypotenuse of a triangle, right? So it is given as 3 by 5. So opposite side is 3 and the hypotenuse is 5. So what is the value here? You know about Pythagorean triplet. What is it? 3, 4, 5, right? So the value here will be 4. Or else you can apply the Pythagoras theorem. Using Pythagoras theorem, you get the value of this base, right? How will you obtain? Root of 5 square minus 3 square. That is root of 25 minus 9. That is equal to root 16. That is equal to 4. So you got the value of base. That is nothing but 4. From this, can you write what is tan x? What is tan x? Tan x is opposite by adjacent. Right. So what is the value of tan x? Here opposite side is 3 and adjacent side of angle x is 4. So it is 3 by 4. It is 3 by 4. So we got the value of tan x. It is nothing but 3 by 4. Now we have to obtain the value of tan y also. That is, if I put cot inverse of 3 by 2 by, we can write 3 by 2 is equal to cot y, which means 2 by 3 is equal to, reciprocal will give you tan y. So we have obtained the value of tan x as well as tan y. Why we are obtaining this tan x and tan y? You might have a doubt, right? Since the question is tan of something. So we have to apply an identity in terms of tan. Okay. We have to apply an identity of tan. So that's why we are finding out the value of tan x and tan y. Okay. So now we have obtained the values of tan x and tan y. Now we are know the identity tan of x plus y is equal to tan x plus tan y by 1 minus tan x tan y. We know the identity tan of x plus y is equal to tan x plus tan y by 1 minus tan x tan y. Here you can see that it is in the form of tan of some x plus y, right? Isn't it? The question is in the form of tan of some x plus y. And here we have given sine inverse of 3 by 5 as x and similarly cot inverse of 3 by 2 as y. So we are applying the identity tan of x plus y. Now I hope it is clear to you why we are using tan of x plus y, because we have given sine inverse of 3 by 5 as x and cot inverse of 3 by 2 as y. Now it became as tan of x plus y. Right. It is in the form of tan of x plus y. So here we have already got that values of tan x and tan y. So we are substituting it. Tan x was 3 by 4, right? Tan x was 3 by 4. Then tan y was 2 by 3 by 1 minus 3 by 4 into 2 by 3. 1 minus 3 by 4 into 2 by 3. So what is the answer for this? We have to solve this, right? 3 by 4 plus 2 by 3. How will you solve this? Either you can cross multiply this or you can solve divided by this 3 and 3 got cancelled. So it will become 1 minus 2 by 4. That is 1 minus 1 by 2. That is 17. 9 plus 8 is 17 by 12 whole divided by 1 minus 1 by 2. 1 minus 1 by 2 is nothing but 1 by 2, right? So 17 by 12 divided by 1 by 2. That is 17 by 12 into 2 by 1. So what is the answer? It is nothing but 17 by 6. Right? We can cancel it. So it is 17 by 6. So have you got this? Here we substituted x as sine inverse of 3 by 5 and y as cot inverse of 3 by 2. From that we obtained the values of tan x as well as tan y. And since this is given as x and this is given as y, the question now became in the form of tan of x plus y. Okay, it became in the form of tan of x plus y. So we applied the identity of tan of x plus y, and by putting the values of tan x and tan y in that particular identity, we solved that and got it as 17 by 60. Okay, the value is nothing but 17 by 60. Next question, sine of pi by 3 minus sine inverse of minus 1 by 2. Sine of pi by 3 minus sine inverse of minus 1 by 2. Again, we have to solve from the values inside the bracket, right? So, what do you know about sine inverse of minus 1 by 2? What is the value? Let sine inverse of minus 1 by 2 be theta. Sine inverse of minus 1 by 2 be theta. Then minus 1 by 2 can be written as sine theta. Minus 1 by 2 can be written as sine theta. So which is the value for sine? That will give you 1 by 2. Sine which value is 1 by 2? Sine pi by 6 is 1 by 2. Right. So instead of 1 by 2, I am writing sine pi by 6. That is equal to sine theta. Now by using the property sine minus sine x is equal to sine of minus x, right? So we can write this as sine of minus pi by 6 is equal to sine theta. So what is the value of theta? Theta is equal to minus pi by 6. Theta is equal to minus pi by 6. Okay, so I'm going to substitute that value in the question. We have got theta is equal to minus pi by 6. So sine of pi by 3 minus pi by 6. Right. Sine inverse of minus 1 by 2 is minus pi by 6. Here there is already a minus. So minus pi by 6. So this will become sine of pi by 3 plus pi by 6. Pi by 3 plus pi by 6. So taking the LCM we will get sine of, this is 6. So this will become 2 pi, right? 2 pi plus pi. That is sine of 3 pi by 6. Here we can cancel it with 2. So sine of pi by 2. So what is sine pi by 2? Sine of 3 pi by 6 can be written as sine of pi by 2. So what is sine pi by 2? Sine pi by 2 is 1. Right. Sine 0 is 0 and sine pi by 2 is 1. So we got the value of sine of pi by 3 minus sine inverse of minus 1 by 2 as 1. Now we'll do some problems from the miscellaneous. Okay. You have some miscellaneous exercises. So we'll do some problems from that. This is the fourth question in your miscellaneous. That is, prove that sine inverse of 8 by 17 plus sine inverse of 3 by 5 is equal to tan inverse of 77 by 36. Sine inverse of 8 by 17 plus sine inverse of 3 by 5 is equal to tan inverse of 77 by 36. Okay, so sine inverse of, let sine inverse of 8 by 17 be x. Sine inverse of 8 by 17 be x. So we can write this as sine x is equal to 8 by 70. Isn't it? We can write sine x as 8 by 70. Now what? We have to find out the value of tan x. For that, I am considering a triangle. So let this be x. Okay. Here we have given that sine x is 8 by 17. So 8 is the opposite side and 17 will be the hypotenuse of the triangle, right? So 8 is the opposite and 17 is the hypotenuse. So how will you find this base? By using Pythagoras theorem, we can find the base, right? How you find it? It is nothing but hypotenuse square minus height square. That is 17 square minus 8 square. 17 square minus 8 square. That is equal to root of. This one is 289 and 8 square is 64. So on subtracting 64 from 289, you'll get 225. And what is the value of root 225? Square root of 225 is nothing but 15. Okay, so we obtained this side as 50. So can you say the value of tan x? Tan x is opposite by adjacent. So here it is 8 is the opposite by 15. Tan x is equal to 8 by 15. So have you all got this? We have found out the value of tan x by using the Pythagoras theorem. Okay. Now let sine inverse of 3 by 5 be y. The second term in the question was sine inverse of 3 by 5. So let sine inverse of 3 by 5 be y. Similarly, we have to find out the value of tan y. So from this you can write 3 by 5 is equal to sine y. 3 by 5 is equal to sine y. Right. So if you consider a right triangle and let this angle be y, here it is given as 3 by 5. Sin y is 3 by 5 means opposite side is 3 and hypotenuse is 5. So we know that this one will be 4 by applying the Pythagoras theorem, or we already know that Pythagorean triplet, it is 3, 4, 5, right? So it is 3 and 5 is given. So the base will be 4. So we got it as 4. Now what is the value of tan y? Tan y is equal to opposite side by adjacent side, right? Opposite side is 3 and adjacent side of angle y. Adjacent side of angle y is 4. So this will become 3 by 4. Tan y is equal to 3 by 4. Okay. Now, sine inverse of, this was the left hand side of that problem, sine inverse of 8 by 17 plus sine inverse of 3 by 5. This was given as x and this was given as y. So we can write this as x plus y, right? So, and we know tan of x plus y is equal to tan of x plus y is equal to tan x plus tan y by 1 minus tan x tan y. Tan of x plus y is equal to tan x plus tan y by 1 minus tan x tan y. Okay. So here I am going to apply that tan x. We got the value of tan x, right? What was the value of tan x? Tan x was 8 by 15 and tan y was 3 by 4. 8 by 15 plus 3 by 4 divided by 1 minus 8 by 15 into 3 by 4. Now what we have to do? We have to simplify this part. Okay. That is, it was 8 by 15 plus 3 by 4 divided by 1 minus 8 by 15 into 3 by 4. Right. So on cross multiplying, we get 32 plus 45 divided by 15 into 4. You can write 15 into 4 as such. Then divided by, this one can be written as 1 minus 8 into 3 is 24 by 15 into 4. Okay. So this can be again simplified as 32 plus 45 will become 77 by 15 into 4 divided by this one will become 15 into 4 in numerator, 15 into 4 minus 24. This is just simplification, okay? Simplification of fractions. So 77 by 15 into 4. So this 15 into 4 and 15 into 4 gets cancelled. Right. So 77 by 15 into 4 minus 24. Right. So that is 60 minus 24. So this will become 36. 15 into 4 is 60. 60 minus 24 will become 36. So it is 77 by 36. Okay. So we got the value as x plus y. So tan of x plus y is 77 by 36. Right. So we can write x plus y is equal to tan inverse of 77 by 36. Tan inverse of 77 by 36. And what is x and what is y? What is x and what is y? We have substituted it, right? X plus y is equal to tan inverse of 77 by 36, and x was, we substituted it as sine inverse of 8 by 17, and y was sine inverse of 3 by 5. So x plus y is equal to tan inverse of 77 by 36. So we started from LHS and we now got it RHS. Got the RHS. So hence we have proved it. Okay. Is that clear to you? Similarly, you can find other problems like this itself. I think four or five problems are like this. I'll continue it in the next class. Okay. We have to do some more miscellaneous exercise questions. So we'll continue it in the next class. Okay. Thank you.